everybody. So this is our intro video to get us into solving 2x2 systems of equations by using the elimination method, aka the addition method. So the big kind of idea, the big picture of this is that you're going to be adding equations up in such a way that a variable gets eliminated, which means it gets canceled out, it goes to zero, variable's gone, goodbye. So that's kind of the idea. So here's how it goes. So steps. First step is write both equations in standard form. So standard form is where you have the variables on the left-hand side, the x and the y are on the left, and on the right-hand side of the equal sign is just a number. So a, b, and c are numbers. Next, this is the fun step. So choose a variable to eliminate and multiply your equations by the right numbers to cancel out that variable. So this is why I love this this elimination addition method, is because it's like a mini kind of puzzle, mini math problem inside of a problem, and I just love that. And I think it's really fun. So here, you're choosing a variable, you're going to choose to either eliminate x or choose to eliminate y. It doesn't matter which one you choose because you're going to get to the same answer in the end anyways. So choose one to eliminate and figure out what you need to make that magic happen, and then go ahead and do that. After that, once you have additive inverses, is what it's called, then you can add your equations, and we're going to add them top down, so right on top of each other we're going to write these problems. And once we do that, one of the variables should drop out, and then you'll just have one variable left so you can solve for that variable. Once you find that one, then you plug it into either equation and get the last variable. And then of course you should always chickadee check before you riggedy wreck yourself. So let's get started. Here's an example. Solve using elimination. So let's see here, a little blue. So again, from the last video and from substitution, I always like to label my equations. This is equation 1 and equation 2. That way I can talk about them, then you know which one I'm talking about. When I say equation 1, it's this top one. So step 1, write both equations in standard form. The x's and y's are on the left, number on the right, x and y on the left, number on the right. Awesome, step 1 is done. And I think for these problems in elimination, I think we set them up for you this way in standard form all the time, so you may not have to do that. If you had some x or y over on one side, you just add or subtract, do the inverse. How do you undo it to get it to the other side? No problem. It's what we did in substitution when you have to solve for a variable. You move pieces from left to right with addition and subtraction. So next, we're going to choose a variable to eliminate and multiply equations by the right numbers. So this should really kind of be in parentheses. You may not have to multiply both of your equations by something. This would be an example where we don't have to multiply both equations. So here, choose a variable to eliminate. So you can choose to get rid of x or get rid of y. I'm just going to choose to get rid of x for this first one. It doesn't matter, I could have chosen y, and I'll get the same numbers in the end eventually. So what we want to do is we want to think about adding these up in such a way that the x's are going to take each other out. So right now there's technically like a 1 in front of this x because there's a 1x there, and this is a negative 4x. And if we thought about adding these equations top down, a 1x and a negative 4x, that's going to balance out to be a negative 3x. So we want to get rid of that x. So in order to get rid of it, we're going to have to make it so that they add to 0. So in order to add to 0, we got to find the number that's going to make that happen. And the way that you can have two numbers add to 0 is if they are additive inverses, which means they're the same number, one's positive, one's negative. So in order to get this to happen, we're going to take equation 1. So this is how I like to write it. We're going to take equation 1, and if I have a negative 4x here, I'm going to want to get a positive 4x here. Well, what can I multiply 1x by to get me to 4x? You can multiply it by 4. So what we're doing is we're taking everything in equation 1 and we're going to be multiplying it by 4. We're going to take that result and add it to equation 2. Oops. So then we can do our addition here. So step 1 is we're going to multiply everything in equation 1 by 4. So 1x times 4 is a 4x. Negative 3y times 4 is a minus 12y. And a negative 2 times 4, don't forget to do the right side, what you do to one side, you have to do the other, is, what's that, like a negative 8. Now, equation 2, we didn't have to multiply anything by because multiplying just the first one by 4 is going to be enough to cancel these out. So equation 2, we didn't touch, that's going to stay the same, so I'm just going to recopy it. And look at that. When we add these up, now we can add them, so this is step 3 here, add the equations top down. So when we add these up, 4x and a minus 4x ends up being a 0x. And if you have 0x's, you don't have to write that. So you can delete that if you want. Goodbye. But I'm going to go back and figure out this stuff. Now I'm going to add the y's top down. So again, these are like terms. Negative 12y, and this is technically like a plus 1y. That's going to balance out to be a negative 11y. And then negative 8 plus, we're adding here, negative 8 plus 19 is about 11, or else 19 minus 8 is 11. And this is kind of step 3 still. So we added the equation top down. Look at that. My x's went away. Goodbye. And now I just got one remaining variable left. Well, my remaining variable left is this y. So how do we get y alone if it's being multiplied by negative 11? You get it. We're going to divide by negative 11. What you do one side, you do the other side. So doing this, these negative 11s will reduce down to a 1. See ya. And then on the right-hand side, a positive divided by a negative is going to end up being a negative, and 11 over 11, again, is 1. So what we end up finding is one value, and we found that y should be negative 1. Once this is now the same thing as the substitution. Once we get a value for x or y, then we can plug it in to either equation and get the last one. So I got y equals negative 1. I'm trying to find x now, so I'm going to do it with the first one, because the first one has a 1x in front, this one has a negative 4x. It'd be more steps if I chose the second equation. So I'm going to go back and choose equation 1, which says x minus 3y, but I now know y is negative 1, equals negative 2. And negative 3 times negative 1, when you substitute that in, put it in parentheses, they're being multiplied if they're sitting next to each other. Two negatives end up multiplying to be a positive. And in order to get x alone, my next step would be to subtract 3. That's a 3, and we're going to get negative 5. So in the end, what we ended up finding was that these two lines intersect at the point negative 5, comma, negative 1. Remember that these always go in x, comma, y fashion. So this is our final answer. Now we have two ways that we can check it. One is we can plug them both in. So I'm going to kind of do that mentally. Negative 5, if x was negative 5 and y was negative 1, this is like negative 5. A negative 3 times negative 1 is a plus 3. Negative 5 plus 3 is negative 2. Yeah, buddy. If I replace this x with negative 5, negative 4 times negative 5 is 20, plus negative 1, if I plug that in for that, is certainly 19. The other way that we can check it is by going over to Desmos. I said that funny, I'm sorry. If you were to plug in both equations, you can see where they intersect. Look at that, chicken dinner, negative 5, negative 1. All right. So there we go. Moving on to the next one. Next page, here we go. So same thing, solve by elimination. So step 1, if you want to pause this video and try this by yourself, you probably can. Otherwise, we'll do some in class too. So write both equations in standard form, check. Check. X's and Y's on the left, numbers on the right. Booyah. Step 2, choose a variable to eliminate. So I got rid of X the first time. Let's get rid of Y the second time, just to show you something different. So so we're going to get rid of Y. That's our choice here. Da, da, da. And now if I want to get rid of Y, let's label these equations first. Equation 1, equation 2. If I wanted to get rid of Y, I'm going to need to add them up so that they'll go away. So this right now is like a plus 1Y and a minus 2Y. If I added 1 and negative 2, I'd get negative Y, which didn't go away. So I'm going to have to multiply something to make that magic happen. So this is where you're thinking in your head, really what we need for this whole thing is the least common multiple. That's what we're finding. What's the least common multiple between a 1 and a 2? Well, it's going to be a 2. So what that means is I want to turn both these puppies into a 2y, where one's positive, one's negative. And the second equation is already in that form, so that's good. So I just got to turn the first equation in the form. What's going to balance out with a negative 2y is a positive 2y, which means I'd have to multiply equation 1 by the number 2. This is a multiplication dot. So let's multiply everything in equation 1 by 2. 2x times 2 is a 4x. 1y times 2 is a 2y. 17 times 2 is a 14. The second equation, we didn't change at all because we ended up with 1 being up there, which is really nice. So we only had to multiply one equation. Again, there could be a time when you have to multiply both, but where the least common multiple isn't something obvious. So that'll be fun. Now when I add these equations up, look at this. The two y's, one's positive, one's negative, cancel out. And then here I can add those up. That becomes a 5x. And over here that's a 20. And this equation is really easy. So that's why I love elimination, man. Once you get rid of that variable, you got one variable left. It's super fast. You're just doing a division here. Divide both sides by 5. You should get x equals Brett Favre, which is the number 4. Take that equation. We're going to solve. Now we're missing y. So I'm going to go wherever y is a 1 if I can. So that's equation 1 here again. So here we got 2 times x, which I found to be 4, plus y, which I'm looking for, equals a big old 7. 2 times 4 is about 8. And if I want to get rid of that 8, I'm going to subtract it. on both sides, and I'm left with y equals -1. So here I end up finding that these lines intersect at the point 4, -1. You can check by plugging it in. Otherwise, look at this. I went straight to Desmos and ding, 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 ding. There we go. That's where those lines intersect. So we did it. All right. So now in class, we'll go over some more. If you have any questions, make sure you star them, write them down, and let me know how you did. Sayonara.